Dr. Ivanka Pelivan is a representative of a focus group on AI for natural disaster management. She is also co-chair of AI for Effective Communication in Fraunhofer Institute for Telecommunication.
Thank you very much for the nice introduction. Also, I really enjoyed your talk about UAVs and AIs and the overview. I should mention that within the focus group, we also see a lot of, I'm trying to share, okay, use cases combining AI and UAVs. So yeah, I hope but today I will give a more of a general overview of the focus group and then show two use case examples we have collected. So so the focus group's name is AI for Natural Disaster Management, and we refer to natural disasters as damaging physical events of predominantly natural origin. So they can be atmospheric, hydrological, geophysical, oceanographic, or biologic. Impacts of natural disasters include injury, mortality, displacement, damage to property, infrastructure, and disturbances to nature and natural resources. The situation is particularly acute in small island developing states and least developed countries and for vulnerable populations. And it is expected to get worse due to population growth, rapid urban development, and climate change. Consequently, they are addressed in the activities of many UN organizations and programs, including the Sustainable Development Goals and policy guiding publications. Advances in algorithm development, growth in computational power, and the availability of large datasets has led to an increase in the use of AI in many fields, such as healthcare and finance. With respect to natural hazards, questions to address include if we can improve our understanding of natural hazards, our ability to detect events in real time and to forecast events, and can we also improve our ability to effectively communicate an impending or ongoing disaster? What are the best practices and limitations of AI in this field? In the article Advancing AI for Earth Science, a Data Systems Perspective, published in the February 2021 issue of EOS, priority areas include creating documentation with standards and repositories to facilitate sharing and discovery, generating new benchmarks, and developing architectures and frameworks cater to the needs of geospatial data. So we are going to explore best practices in data collection, handling, and pre-processing, taking into account what requirements should data meet when being used to train or test an AI-based algorithm. Can AI-based algorithm be used to enhance data quantity and quality? When it comes to algorithm development, for detection and forecasting, questions to explore are: what is the current gold standard method to detect or forecast events? How can AI-based algorithms bring these methods to the next level? What should be considered when training and evaluating an AI-based algorithm? And finally, targeting communications, we're looking at once an event has been forecast or triggered, how can AI assist with the immediate response? For instance, through automatic translation, AI-enhanced dashboards, or decision support systems. And how do we ensure that communication methods are reliable and trusted by the population? Are they accompanied by a clear set of protocols to ensure that individuals know how to respond? So these topics are going to be explored in a set of deliverables inside the focus group, including workshops, a roadmap, several non-normative technical reports, and education materials. To achieve this, we're bringing together experts and stakeholders from different fields. The focus group provides an ideal platform for such an exchange. It supports the efforts of an associated ITU study group. Our study group, which is study group 2, has a mandate which includes telecommunications for disaster relief, early warning, network resilience, and recovery. Focus groups provide a working environment for pre-standardization and standardization activities in a chosen area, and they can be rapidly established and have the freedom to choose working methods, leadership, financing, and desired outputs. This focus group is unique in that It's bringing together the ICT expertise of the ITU with the natural disaster expertise from WMO and UNEP, and it provides a platform for international multi-stakeholder and interdisciplinary collaboration. So who's behind that? The focus group is chaired by Monique Kuglic, my colleague at Fraunhofer, and several vice chairs from different countries and organizations, including the WMO and UNEP. The focus group has a multi-tiered structure. At its core are the topic groups, which are clusters of experts who explore how AI is or could be used for a specific application through use cases. So I may have mentioned that we do see quite a lot of use cases combining AI and UAVs, for example, in the field of wildfire detection and situational awareness, or in the areas of insect pest detection, to name a few. In the following, I want to share with you two use case examples. One belongs to the topic group for flood monitoring and detection and deals with flash flood warning in Colima, Mexico. And the second use case applies AI methods to improve snow avalanche detection in Norway and Switzerland. Urban flooding is one of the major issues in many parts of the world, and its management is often challenging. In this use case, an Internet of Things approach for monitoring urban flooding in the city of Colima, Mexico is used. A network of water level and weather sensors has been developed along with a web-based data platform. In this testbed, IoT techniques are used to retrieve data through 3G, 4G, and Wi-Fi networks. Machine learning algorithms are integrated into the system for short-range water level predictions at different nodes of the network. This slide shows the main dashboard of the web-based platform. It shows a map with markers, which show the position of each node registered on the platform. The markers change color according to the warning level of this corresponding river section. The icons are clickable to show the station data. The site is intended to be shared and consulted by the general public. And the goal here is to establish an affordable, functional system providing warnings in real time. It's intended to help decision makers, government officials, and the general public to properly plan in the case of an emergency, evacuate in time. And the system is under development with respect to machine learning to try out different methods to decide which works best. Additional data sources will be added, and additional features deemed helpful by current users can be incorporated. And I have just been told that the initiators of this system have been asked to establish the system in another city in Mexico, so this really is a great success. The second use case I would like to show is a combined effort between Norwegian and Swiss researchers in advancing the science of snow avalanche detection and forecasting. To warn the public about avalanche danger requires data on weather, snow stratigraphy, and avalanches themselves. Data sources are ground-based data such as radar, seismic, or infrasound for near real-time detection, and satellite-based such as optical or radar imagery for large-scale monitoring. Methods applied include hidden Markov to automatically identify seismic events and convolutional neural networks to automatically identify avalanches in radar data. The challenge is that very little avalanche data is available when and where it is needed. To overcome this challenge, the Institute for Snow and Avalanche Research in Switzerland is developing a low-cost ground-based avalanche detection system alongside machine learning methods to advance avalanche science. The machine learning algorithms will be implemented in the operational avalanche forecasting service at the SLF Switzerland. The avalanche activity monitoring system using satellite data is already operational in Norway, and here research is ongoing in improving avalanche detection, for example, for the detection of small avalanches that also are missed by human image inspection. I guess here also the use of UAVs could help. So I hope I could spark your interest a little bit, and in case you want to get involved in the focus group or would like to participate in one of our next workshops where new use cases and great examples are also displayed, you can visit our website or you can also contact me directly for any questions. Thank you very much.
Thank you very much for this very informative presentation. Just maybe a quick follow-up question: Is anyone can join your group, or is it for some particular group of users?
No, it's free to join, and it's open to all that want to participate and contribute to one of the deliverables.
Great. So
just maybe one note that during the next meeting, which is probably in April or May, it will be last chance to submit an interesting use case if anybody is considering. Yes, definitely. So the use cases I presented, I tried to bring in some variety. So the use cases I presented, they ingest data from different sources. So while the avalanche use cases, in this case, they do not use UAV, but I think they investigate this possibility to do this on certain sites, because some of the challenges they identified is that they do not see the small avalanches from satellite imagery. And then there's, of course, areas that are not accessible for ground sensor measurements. The other use case, the flat use case, they also digest all kinds of different data streams from weather data and ground sensor data. And I think this is one of the options. They also have to use this as an additional sensing source. And then within our use cases that we have already internally vetted are also applications. I think I mentioned the insect pest detection in the forests, where they use UAV because of the closer imagery, and that they can span a wide range of vectors to investigate. And they do have also satellite imagery, but they don't see. It's too far away to really see if an individual tree is infected. But if they use field work, they cannot cover a broad range of areas. So they had good success in using UAV imagery. And then I think we have a proposal right now, which is using UAV for forest fire monitoring. So there's a lot of use in this area.